So the next part of this is to try to download the entire data set into a Torch tensor, and I don't think I've got PyTorch available, so I've kind of like been doing little lookups. I've kind of like gone here, I sort of like Googled PyTorch, and it kind of like leads me here, this PyTorch website. It looks a bit, I'm going to say like there's a lot of bits here. And it talks about a CUDA capable system, and I'm not even sure which one I necessarily have, but if you do the open link in new tab here, CUDA is a parallel, and I don't even know what CUDA is necessarily. CUDA is a parallel platform and programming model designed by NVIDIA for general computing on graphical pro GPUs. With CUDA, developers are able to dramatically speed up computing applications by harnessing the powers of that. Okay, and languages are C, C++, Fortran, Python, and MATLAB, and express parallelism through these extensions. Okay, so the other alternative is, well, I'm not sure if this is going to work or not, but pip install Torch. And literally, like whenever I try to install any applications that I've not installed before, I just sort of like type pip install of the application name and see what it pulls up. It's taken up me to the pypo.torch object. PyTorch is a Python package that allows two high-level features. Tensor computation like NumPy with strong GPU acceleration and deep neural networks based on a tape autograd system. So it looks like it's the right thing here. So I'm just going to copy that, and I go over here, and I think I need to be in the terminal and attempt to do a pip install of Torch, and we'll either survive or we will fail on this one. So we're running here, doing a download, kind of like looking good so far. Hopefully I don't have to, some videos do the pause and restart because it takes so long, so I'm hoping that that's not going to be one of these ones. And if it does work, then I should just be able to import Torch in here and just basically try and run it. So there's also the pytorch.org website, so let's just go, I'm going to Google on the side pytorch.org. I think we were already there. Yeah, we were. So anyway, it looks like it's doing its thing. It's not quite done though. It's hanging around over here. I can hear the PC whirring, so I'm presuming that the install is happening. And I wonder if by the way, these are the sorts of things that, you know, when we look at the videos, we get the high level overview, which is fantastic. This is actually the mechanics of what you'll be doing on the ground, because it won't be working and you've got to get it working. Yeah, and one way of avoiding this was to use like Google Colabs, which would have come with PyTorch. It looks like it's done there, successfully installed. Markup safe. So everything looks like it's good there. Yeah, as I was saying, you could use Google Colabs, which comes with a lot of things, but there's just a bit of extra freedom when you are, you know, using VS Code and Python downloaded onto your own system. So let's just try import Torch. Looking good because it's there, and then we can do something like data equals torch dot, oh no, looks like Torch hasn't been acknowledged. Maybe I have to do a restart of the system to get that working. Right, so I just did a restart. I'm hoping it works now. I did a restart and I ran through all of these modules. I literally just closed down this this notebook and then reopened it, and it looks like okay now. So let me just try and do the same again. So we'll say that data equals torch dot, and then we want tensor, so tensor, and then we're going to call our encode function. This was the function that we created up here. So we're going to encode, but instead of encoding hello world and just getting our little string of hello world over here, you can see, by the way, in hello world, this space, we can see the number 1, which was, you know, the space was over here, number 1. So that was kind of like visible. So it's nice to see our encoding thing working. So we're going to pull in our encode of text. So encode and text, which is all of the text. If we recall, just scrolling all the way back up, here text equals r.text, and that is all in the memory because I did rerun it all. So text over there, and then I'm just looking at like the side bit, the help bits, but there's a D type, so D ty D type. We sort of like see it in the pull-up thing as well, so we could sort of like look into TensorFlow, like, you know, what there is. TensorFlow.tensor. I wonder if I can scroll down. We've got D-type device. Sometimes on this thing it doesn't like pop up very nicely. We've got device as well as options, which defaults to none and then requires grad. I think this might get used later in the tutorial actually. Underscore bool, so it's a boolean. It's an internal data type if it's got an underscore. So anyway, we've got a D type, and the D type is going to be a torch. It's going to be a long, so it's going to be a torch.long, I think, because torch has its own types, basically long. So long, torch.long. So, and then let's just print. We'll just do, well, first, I guess we'll do, let's just do data. Just see what comes out of that. Right, so a lot of thinking. And there we go, we got a tensor that comes out of it. So we can also do print, well, I should have just done it around it basically, but data dot shape, and then data dot d type. Right, so rather than just having data, we've got the shape of the data, and which we know is a tensor. Print the data, and that is just data, so we'll just do that. It's going to run for a few seconds, I guess. Maybe we'll print these all on different lines. Well, let's just run this. Hold on, let's have a look and see. So I'm just going to split this out. So we'll do just so that we've got it all there. The shape, and then we're just going to export this onto another line just so that it's X basically over there, and then do print just to see what we get out. The D type colon, and then we'll just select through that, so we can see all of that explicitly. Basically, we'll put two commas there. So we got the date and the D type, and then we can also print out. So we'll see that that's our million characters over there. Which was a number that we had right in the beginning when we sort of like counted our number of characters somewhere. There was our len 1115394. So it's the same thing that leave down below, 1115394, and it's the data type is int64s. So I guess that just makes it presumably more efficient, I'm imagining. And then finally we can do print, so we can see now our data. But if we did data, well, we did it before, and we saw that we had this tensor thing over there, but it was kind of like massive. So let's just sort of like print out the first 100 characters. So colon 100, like this. I won't fit like loads more, I don't think, on here. Let's close. I could open up the Jupyter variables back again. Maybe data. Well, data exists in here. Let's have a look. That's going to be pretty massive, probably. Hope I haven't. Yeah, I mean, this is going to be absolutely colossal. So I'm not sure that was a good strategy, because that's basically all of the data. So maybe I close that because it's too big. Let's print this data this way. So we're going to print now kind of like the first 100 items from this list, effectively, because this is a list, this tensor. So let's just run that, and there's the first sort of like 100 items from there. And like number 18 is, again, if we kind of like go, where was 18 on here? We had to scroll across to 18, but I guess the first character of whatever was in there, it begins with a capital, and so it's an E, a capital E. And if we were to scroll right up to our text somewhere, although I'm not seeing it because it looks like an F here. Oh yeah. I wonder if 18 actually refers to one below it, because we were there and we got to 18 over there. Oh no, that's right. 17 is an E and 18 is an F, so that's perfect. So it kind of like looks like it matches, and we've got our data into a PyTorch tensor. So we've completed one extra stage